Mount Vesuvius, Mount Fuji, and Mount St. Helens.
The images that you just saw are absolutely gorgeous, but don't be fooled. Those mountains are volcanoes, one of Earth's most destructive natural disasters. Volcanoes are defined as a rupture in the Earth's crust that allow hot lava, volcanic ash, and gases to escape from the magma trapped below the Earth's surface. When this happens, the Earth shakes, the landscape all around the mountain burns, and all living things near the mountain basically become buried in a heap of smoldering ash. The devastation is almost too much to take in, and it's kind of scary. These mountains have been around for hundreds of thousands, if not millions of years, and they're still being made to this day. You're wondering, how are these volcanoes still being formed today, and how are they formed in the first place? Well, that's an excellent question. Volcanoes are formed by converging or colliding plate tectonics in a process called subduction. During this process, one part of Earth's crust sinks below the other with a variety of combinations. There could be an oceanic plate versus an oceanic plate, a continental plate versus a continental plate, and mixing things up a bit, even an oceanic versus a continental plate. Now, when these plates collide, a variety of combinations can happen. During a continental-continental collision, mountains are formed. During an oceanic-oceanic, a mid-oceanic ridge can form. And during an oceanic-continental, this is where we see most volcanic activity. During an oceanic-continental collision, the oceanic plate tends to subduct due to a high density of its basaltic makeup. The oceanic crust then sinks below the continental crust, bringing a lot of water and remaining hydrogen particles with it.
This diagram helps explain what I'm trying to talk about. When the water subducts along with the oceanic crust, it lowers the melting point of the mantle, creating magma. The magma would then rise, causing a deformation within the continental crust due to depressurization, and a volcano starts to take shape.
These volcanoes do not always form in the same way. In fact, when they do form, they could form a variety of different types of volcanoes. In this case, there are three distinctive profiles to identify a volcano: shield volcanoes, cinder cone volcanoes, and composite volcanoes. The first of which is a shield volcano. And this is the largest of volcanoes on Earth that still actually look like a volcano. And it definitely kind of makes a mountain out of a molehill, because it's not that mountainous. In fact, if you look here at this crude drawing I have done, you can see that the shield volcano resembles much of a hill-like formation with a small crater at the top leading towards its magma chamber there. And what I mean by this is that these volcanoes consist mainly of mafic lava, and have generally a low viscosity when it comes to lava flow. Because of this, the lava isn't capable of getting that steep. It's basically like trying to pile up a fluid that runs easily downhill. And I do a pretty good job of explaining this in this demonstration here.
We have a cup of generic maple syrup, a mixture that is less viscous than lava, but more viscous than water. Hopefully, I am going to demonstrate what a shield volcano would look like after an accumulation of enough mafic lava. Now, if you look closely, the syrup will refuse to build upward. However, it will gain some height in itself. Now, after enough accumulation of mafic lava, this hill will start to rise slowly, but probably won't reach the steepness of a stratovolcano or a cone volcano.
Classification would be the cinder cone volcano, which is the simplest type there can be. Due to its felsic makeup, it allows for it to be much steeper, with a bowl-like crater at the top, which makes for a slightly more dangerous volcano, but we'll get into that in a minute. And the last classification of volcano would be the composite or stratovolcano, which is the most abundant type of volcano there is. It is the most symmetrical of all the volcanoes, and certainly the steepest of the three classifications. Due to its high felsic makeup, it allows the mountain to rise over 8,000 feet above their bases. These volcanoes are made from alternating layers of lava flow, pyroclastic material, which is like ash and ash-like debris, and actual debris. But despite that, they are absolutely beautiful to look at. The mountains I mentioned earlier, Mount Fuji, Mount Vesuvius, those are all stratocomposite volcanoes, and as you can see from those pictures, they're absolutely gorgeous. But like I said earlier again, they are deadly for a reason. In my personal opinion, I think all volcanoes should be considered dangerous, be them dormant or active, but usually the level of danger is dependent on their lava content. For example, a volcano with a less viscous lava and a low silicate content, like mafic lava, would have trouble exploding to the level of the volcano in, say, Jurassic World. Due to its low viscosity, the eruption of a mafic volcano would most likely just produce a river of lava. This would be known as an effusive eruption, a non-violent eruption, basically.
Now, when I say non-violent, I don't actually mean non-violent. What I really mean is less violent. As you can see here, this is a picture of an effusive eruption in Hawaii. Now, clearly it is not non-violent, as you can obviously see a lot of damage happening. But it is not as damaging as an explosive reaction, which is what we will be discussing next.
Now, the more dramatic eruptions that you see on movie and television series, those are known as explosive eruptions, and they're known as that because, well, you guessed it, explosions. Now, explosive reactions are usually caused by the high felsic content in these volcanoes. In fact, the more felsic a volcano is, usually the more explosive it is as well. In fact, if you were to stand close to an effusive eruption style, honestly, you could probably just sit there and stare at it like they do in Hawaii on the little coast there. However, if you were to stand next to an explosive eruption style, well, then you would truly see just the horror of Mother Nature.
Now, I've been told that Jurassic World has some factual inaccuracies, but for right now we're going to work with this image. Now, what they're trying to portray is a explosive eruption style, and I think they're doing a pretty decent job of it. Now, what would be happening here would be that the viscous lava in the volcano would allow gas to build up so much to the point where it would explode out the top and the sides, sending lava and pyroclastic material and debris and blocks of ash just raining down everywhere, smothering the land around it, and the whole affected area would just be absolutely devastated.
During this mass devastation, environments, animals, people, ecosystems, they're all being destroyed by lava and ash. Cities miles away, people hundreds of kilometers away are being affected just terribly by this eruption. And we have no idea what to do about it. These mountains have been around for years and years and hundreds and millions of years, and they're gonna be around much longer than we are. And clearly, they're a force to be reckoned with. But fortunately, we humans aren't idiots. We have thought of ways to counteract these eruptions and try to stop this devastation from occurring on such a large scale. The CDC and National Geographic alone have put out a myriad of tips on when and how to evacuate when this type of situation occurs. Not only this, but they've also gone further and given tips on how to survive it if you are forced to stay in your current location. But we are trying to go past this. We're trying to predict when these eruptions will occur and maybe even stop them from occurring. Right now, I know that Michigan Technical University is trying to work with a decompression idea, trying to release the buildup of gas that will hopefully lessen the eruption, if not completely get rid of it. But they are going even further than that. They are trying to figure out a way to extract the thermal energy from the heart of the volcano and turn it into renewable energy, which I think is pretty cool. At the Michigan Technical University have even started playing with these ideas, conducting experiments on mountains and in Japan. In the end, that's all we could really do as humans. Try to predict and maybe even counteract these eruptions from these beautiful, gorgeous mountains that have been here way too long. But people are still living near these mountains, despite the dangers, and good on them. But
fortunately for me, I don't. And I never will have the desire to, thanks to Jurassic World, because even though it is factually inaccurate, it still scares the heck out of me. So, this has been my video on volcanoes. I hope you enjoy it, and thank you.